Hi everybody, my name is Bhavishya and in this lecture we will see different types of states from which a router goes to achieve the state of fully synchronized. Okay, so let's begin. So this is our topology. Here I have only configured OSPF on router 1 and let's see what is happening in the backend with Wireshark. So as you can see here, we can only see that our router 1, this is the IP address of router 1, is sending hello packets to our R2. But we cannot see any update coming from R2, right? As it is not configured yet with OSPF, right? So what is inside this in Ethernet? As you can see, type is IP address 0800. In the IP protocol, as you can see, the protocol that we are using is 89, that is OSPF. And if you look at the header part, let's see what is carrying. The message type says 1, which is hello packet. So there are 5 different types of packets that it can send in OSPF. The very first is hello packet with value of 1. The 2 specify database description packet. The 3 specifies link state request packet. 4 states link state update packet. And fifth and the last one, number 5, state link state acknowledgement packet. Right. So now let us go and configure our R2 for OSPF. Let me pause it. Okay, so we'll go to R2. We will say instead of no network, now we have configured the network. Enter. Okay. Makes sense. Before this, I have to go and say router OSPF1, then this network. Great, makes sense. Now if I go and check what's happening inside, so many things happen, right? Let me expand it. So as you can see, initially it was sending R1 was sending hello packet to R2. Then at this particular, where it is, at this particular the 17th packet came from R2, right? Via multicast address only. And then we can see database description packet, request packet, acknowledgement, update, and so many more. So let us understand what is happening. Let me minimize this a bit. Okay, so what is happening in the backend is R1 sent it very first hello packet to R2, right? Now R2 accepted the R1's frame, and then as it accepted the R1's frame, it put R1 in the init state. Now this init state means initial state, right? Now after that, this is in this. Now in this, as you can see, the source is R2. R2 sent in hello packet to R1. R1 received the R2's hello packet and then puts R2 in the init state. Now both of these are in the init state, that is initial state. After this, now this was the, I guess we have to redo it. Or let me take it. Okay. Hmm. Now R1 will send an hello packet to R2, but the difference here will be if you look at the hello packet of R1 at that time, you can see a field called active neighbor, which says, okay, this is my neighbor and this is the router ID of that neighbor. So in this state, when R1 is sending a hello packet to R2, you can clearly see in the active neighbor it is the router ID of R2. So when R2 will see that, okay, in R1's hello packet, it contain my own router ID. So that means that R1 is indirectly acknowledging that it has successfully received R2's hello packet, and, and by result he kept R2 in its active neighbor, as you can see via router ID. So what will happen? R2 will receive R1's hello packet, and then R2 will transit its state from init to two-way. So two-way is basically that two routers, this R1 and R2, has become neighbors officially now. Now after that, R2 will send its hello packet to R1. Suppose here you can see. And in its hello packet, in R2's hello packet, you can clearly see the active neighbor is R1's router ID. So when R1 will see that, okay, in R2's active neighbor, it has my own router ID. So then R1 will transit R2 state from init to two-way. Now both of these are in from two-way to from init to two-way state, and two-way state means that both of the routers means two routers has become neighbors now, right? So if I want to summarize, so init is the state when, let's suppose R1, okay, let me put it this way, show IP OSPF neighbor. Here you can see the state says full, that is fully synchronized. But before this, what is happening is the very first is init state. Let's suppose R2 is in init state. That means it has successfully received R1's first hello packet, where in the active neighbor field was not active, right? Now let's suppose R2 is in two-way state. What does this mean? This means R2 has successfully received R1's hello packet, where in the active neighbor field R2 can clearly see that it contains its own router ID. Right. Now let's suppose we have a special case where in R1 the state is two-way, great. But if you look at R2, the state is two-way, let's suppose. Instead of two-way, the state is init, let's suppose. R1 is in two-way, R2 is in init. So in this case, what is happening? R1 has successfully received R2's hello packet, where it can clearly see its own router ID. So this is the reason R1 is in two-way. But regards to R2, due to some reason, maybe it got shut down or the frame or the hello packet got dropped or anything, he was unable to receive R1's hello packet, where he can clearly see that it has its own router ID. So this is the reason why R2 is in init state only. So this was a brief introduction about the states of the router go through to achieve the full state. So full state basically means that it is fully synchronized. Our R1 and R2 goes through from init state to two-way state, then from Xstart stage to exchange state, from all the states up to full, where it is fully synchronized and they have successfully synchronized each other's databases. Right. So this was it for this lecture. I hope you enjoyed. See you in the next one.